Welcome, guys. We are still working with solving for roots. And remember, other names for roots are x-intercepts. We also call them solutions. What else do we call them? Oh, yeah, zeros, right? Because we always make them equal to 0. We make one of the y values 0 when we graph it or when we solve it, right? All right, so today we are learning how to solve for that x value, right? That solution, that 0, that root, using the square root, which we've used at the beginning of the year, throughout the year. So that's another one of those things. So think back of what we learned in the beginning of the year. Think back of when you first heard square root, some of you in middle school, right? And now we're going to bring it to the next level. Okay, so I want to show you the method that we just learned called difference of two squares, dots, right? Difference of two squares. And also the new method. Now, you get the same answer no matter what method you use. You would get the same answer if you put in your calculator y1 equals x squared minus 16. And in this second one, you put y2 equals 9, right? And wherever those cross, those would be your solutions, right? So there are so many different types of ways to do this. And we are really going to focus on two of them. One you just learned and one that's new, but with hints of things that you've learned before. All right, so let me erase this so we can really get started fresh. Okay, so difference of two squares, let me just erase that. Difference of two squares is looking for the difference of two perfect square terms. Okay, this is one where this side has to be 0. Okay, so I'm going to just subtract 9 on both sides, subtract 9 on both sides. Okay, oops, why did I do that? Sometimes it's hard to do math and talk at the same time. Okay, so 9 minus 9 is 0. And here I've got x squared. Now, negative 16 minus 9, okay, they're both the same sign, so I'm going to add them and keep that minus sign. Okay, so now I've got x squared, which is a perfect square, right? I could say x and x is x squared. And 25 is a perfect square because 5 times 5. So I've got two perfect square terms with a difference in the middle of them. So that is where we can use difference of two squares. Okay. Now I can use my box method, my area model. And I put my first term in the first box, my last term in the last box. And normally I like it when you guys play around with this, but since it's not the method that we're focusing on today, I'm just going to go a little faster. So remember, inside is my standard form, and outside, let me make it blue, are my factors. So x times x gives me x squared, and 5 times negative 5 gives me negative 25. Now that's important because when I fill in these other two boxes, I'm going to cancel out. That's why there's no middle term. Okay, so here I have 5 times x is 5x, and negative 5 times x is negative 5x. 5x minus 5x cancels out, leaving me with x squared, right? I see that here and here, and a negative 25 here and here. So my factors are x plus 5 times x minus 5. And I'm just going to erase this so you can always press that pause button. Okay. Equals 0. Now, remember the ZPP, the zero product property, says that I can take either parentheses and set it equal to 0. This does not work for any other number but 0. So I've got x minus or plus 5 equals 0. And then I'm going to do this one over here, x minus 5 equals 0. All right, so now I'm just going to solve minus 5 minus 5. Let me squeeze it in. X equals negative 5. So one of the roots, right? So if I'm doing this, one of my roots would be at negative 5. Okay. And then the other one, add 5. X equals a positive 5. So my other root, my other solution would be a positive 5. All right. And do you know which way it's facing? Is the parabola facing like a U, like upwards, or is it facing downwards like an upside down U? All right. Hopefully you said it's facing up, so it should be something like my sketch here, because the x squared term is not negative. If it were negative, then you'd be facing down. All right, so now let's get to the square root method. All right, so I've got x squared minus 16 equals 9. In this one, I'm really focusing on the square term. All right, so I want to move everything to the opposite side of the equals. So I'm just going to add 16 to both sides. And I've got x squared, I just brought that down, equals 25. Now, I'm just going to do the square root to both sides, because remember, the squared and the square root undo each other, just like subtraction and addition, or multiplication and division, so they undo each other. So I can just do square root here and square root here. Remember, if there's a number in that square root, I've got to put plus or minus. All right, so now the square root is the inverse of the square, so they cancel out, and I am left with x equals a positive and a negative 5, which is exactly what we have. We have a positive 5 here and a negative 5 here. And remember, this symbol means x equals a positive 5 and x equals a negative 5. They just don't like writing it out, so they like using that shorthand of this plus minus right on top of each other. Alrighty, so this is super cool. So now I have not just one term, not just like x squared, but I've got a whole parentheses squared. And we're going to do it the same way. All right, so we're just going to pretend that this whole parentheses is like one variable, right, until we get to the very end. So in dots, if I wanted to do that, minus 1 squared equals 25, I would want to have everything to one side and for it to equal 0. So let me do that. Oops. And there's the square. All right, so I have this whole term squared, right? If I were to do a box, I would have 3x minus 1 and 3x minus 1, right? So even though it's got more than one term in it, it's still a perfect square. So I've got a perfect square here. 25 is a perfect square because 5 times 5. And I've got the difference of that. So my factors would be 3x minus 1 plus 5, and 3x minus 1 minus 5. All right, so remember, 3x minus 1 times 3x minus 1 gives me 3x minus 1 squared. And 5 times negative 5 gives me negative 25. All right, equals 0. So I can now set each of these terms equal to 0, and I'm going to run out of room. So let's just do it, and then I'll erase it. So let me write this. Instead of negative 1 plus 5, I'll just write that as plus 4. And here, negative 1 minus 5 would give me negative 6. So I'll put 3x plus 4 equals 0. Again, I'm using that zero product property rule. And then here, I'm going to write 3x minus 6. Remember, I just combined those like terms, equals 0 as well. Okay, so now minus 4. Ooh, maybe I'll fit it. I don't know. Okay, and then I've got 3x equals negative 4. I am not going to fit this here. All right. And then if I divide it by 3, let me see. All right, so I'll just do it right here. All right, so if I have, don't worry about that, 3x equals negative 4, I can divide both sides by 3, and I would get x equals negative 4/3. So that's one of my roots. All right, now my other root would be 3x minus 6 equals 0. Equals 6, and then divide by 3. And my other root would be x equals 2. So those are my two roots. X equals negative 4/3 and x equals 2. Okay, so I'm going to erase that so I have room to do the square root method. But just know we should get exactly the same answer. Okay. All right, so here we have 3x minus 1 squared equals 25. Now, again, we're treating this whole block like one variable. Like if I wanted to put like a big x over it, right? If this is a big x squared. So I'm not looking at it as 3x minus 1. I'm looking at it as a chunk, as a one being, a one item, right? So 3x minus 1 squared. So 1 unit. There, that's a better word. Okay, so I've got this 1 unit being squared equals to 25. So again, I can do the square root on both sides. Don't forget your plus minus. The square cancels out with the square root. And I'm left with just what's in the parentheses. So I've got 3x minus 1 equals a positive and a negative 5. So if I want to solve that, I really need to actually write out two different equations at this point. So I can have 3x minus 1 equals a positive 5, and 3x minus 1 equals a negative 5. Now I'm just going to solve. So follow along with my solving. In fact, it would be better if you had it already done and were pausing it. 3x equals 6 Okay, so now here I'm going to write over here, I get the x equals 2. Remember I got that in my my difference of two squares? So now this one I'm going to add 1 again. 3x equals negative 4. And when I divide both sides by 3, I get x equals negative 4/3. And if you remember, that's exactly what we got in the other method, the difference of two squares method. All right, so these, if you're like, what's going on? Practice, right? So follow the steps along, rewind it, rewatch it. Okay, so let's move on to the practice. Now, here, I've got a practice. So I have 3/4 x squared equals 48. Okay, so now I'm going to subtract 48 because I know in my difference of two squares, I really want 0 to be here. So 3/4 x squared minus 48. Now, if you notice, 48 is not a perfect square. Right? So if it's not a perfect square, we actually can't do the difference of two squares method. And that's one of the things that you guys should be focusing on, is being able to choose the factoring method that makes sense. So being able to look at something like, where are we? Like this problem where I have a perfect square term and a perfect square term, and I can do a shortcut to know what my factors are. So at this point, you should start recognizing, hey, I think that this method might be a little easier than the other. All right, so I can't do dots. I can still do the square root method. 3/4 x squared equals 48. Now, if you notice, there's no parentheses on this side, right? My only term that is being squared is this x squared. So I've got to figure out how to get that 3/4 to the other side. Whenever I do square root, I always have to have the squared term by itself, okay? Whether that squared term is in parentheses, or in this case, whether it's just the variable. So let me do the inverse, the multiplicative inverse here. So 4 times 3 is 12, right? 3 times 4 is also 12. So I've got 12 over here. We do it to the other side. So 4/3. Okay. Now 48 times 4. Oh, let me get my calculator. I need a little help here. All right. So 48 times 4, I get 192 over 3. Remember, 48 is really 48 over 1. So 48 times 4 is 192, and 1 times 3 is 3. All right. So I'm almost there. So 12 divided by 12 just turns into 1, right? My invisible 1. So I've got x squared. And 192 divided by 3 gives me 64. Okay. Square root method. The inverse of a square is a square root. So I'm going to square root both sides, remembering to put my plus and minus. These guys cancel out. And I've got x equals a positive and a negative. Does anyone know the square root of 64? All right. It is 8. So I don't just have one root, I have two of them. My roots are x equals a positive 8 and x equals a negative 8. Okay, so I've got two of them. this is just writing it once. All right, so this is a common Regents problem. I would not be surprised if you saw this. So we're using the same stuff that we've used in the past slides. And I think for right now, we're actually not going to use dots because I don't want the video to go on too long. But it would be exactly the same way I think we did the example slide. Okay, if you go back a couple slides. All right, so find the zeros. Find the zeros. Remember, it's called zero because we changed the y, right, which is written as f of x in function notation, as 0. So we literally just changed the f of x into a 0. Oops. And everything else stays exactly the same. Okay. Oh, this is I kind of do want to do dots. I love doing all the types of factoring. Okay, no, never mind. I'm not going to do it. We're just going to do square root method. Okay, so let me just rewrite it. 0 equals x minus 3 squared minus 49. All right. So in the square root method, we just want the term that is being squared by itself. Everything else goes on the other side of that equals. Okay, so I've just added 49 to both sides. So here I've got 49 equals parentheses. Remember, this is 1 unit squared. Now, the inverse of a square is a square root. And what I do to one side, gotta do to the other side. And don't forget the plus and minus there. So the square root of 49 is 7. So I've got plus and minus 7. And then the square cancels out with the square root on this side, leaving me with x minus 3. So I can write this out in two different equations. One of the equations would be 7 equals x minus 3. And the other equation would be negative 7 equals x minus 3. If you notice, this side stays the same. I see exactly the same x minus 3. The only thing that changes is one of the equations is a positive 7 and the other is a negative 7. So I'll let you guys do the math, but you should get x equals 10 for one of your roots. And on the other side, you should get x equals negative 4. All right. Again, when you graph this, you should see at where y is equal to 0, also known as your x-axis, you should see at negative 4 and at 10, you should see the quadratic, and I know it's positive because there's no negative here. All right, so I know it goes up because of that. So I know at negative 4 and at 10, it should cross that x-axis. Okay, questions, comments, or concerns? You guys know what to do. Take ownership of your learning. I know that this isn't the most ideal way. Trust me, I would much rather be sitting with you, writing on the desk, going over some problems. But this is where you dig deep. You really take ownership of that learning. You contact us. You phone a friend. All right. So really good job so far. Keep it up and, dig deep. We can do this. Have a good day and get all your work done.